So do you remember that I use that formula when I find out the derivative of e to the x? Limit x tends to 0, e to the x minus 1 over x is how much? So let's plug in the limit directly. You will get e to the 0 is 1 minus 1 is 0 over 0. Okay. So what you do is I want to use the L'Hopital's rule. L'Hopital's rule. Now I want to find out the derivative of the top separately and the derivative of the bottom separately. So what is that? E to the x minus 0. Because derivative of e to the x is e to the x minus derivative of 1 is 0 over 1. So when you plug in the limit, you will get e to the 0, which is 1. Yes, we use that formula. Limit x tends to 0, e to the x minus 1 over x is equals to 1. This is what we used. Do you remember we used this formula too? Limit x tends to 0, 1 plus x to the 1 over x, right? So what do you want to write? You can write this as, before I use the L'Hopital's rule, to use the L'Hopital's rule, I need 0 over 0 or infinity over infinity or one of those form, right? So let's see. When you plug in x tends to 0, what do you get? Limit 1 plus x is basically 1 plus 0, right? 1 plus 0 is 1. So natural log of 1 and then 1 plus x. So basically let me simplify a little bit and then I will plug in those values, okay? So equals to limit x tends to 0, you can move that to 1 over x, you see that, times natural log of 1 plus x. You can write that way. So if you plug in the limit, you will get, what form do you get here? You will get 1 over 0 is infinity times natural log of 1 plus 0 is natural log of 1 is 0, right? So natural log of 1 will be 0. So it is in the form of 0 times infinity, which is the indeterminate form, right? So I want to write this as limit x tends to 0, natural log of 1 plus x over x, because there is 1 in the denominator, you multiply those two, right? If you plug in the limit, what do you get? You get natural log of 1 plus 0 is natural log of 1 is basically 0, right? This is like 0 over 0 form when you plug in that limit. You see that? Now you can use the L'Hopital's rule. So equals to, I want to use L'Hopital's rule. Find the derivative of the top. You think this as u. You see that? You can think this as like u. So what is the derivative of natural log of u? Is basically 1 over u times the u prime divided by the derivative of x is 1. So what is that? 1 over 1 plus x times 1. You see that? So what is the limit? Oh, I forgot to write the limit again. X tends to 0. So when you plug in the limit here, you will get 1 over 1 plus 0 is 1 times 1 is just 1. So the final answer is 1. So you remember that I wrote that formula when I was trying to find out the derivative of a natural log. Limit x tends to 0. Natural log of 1 plus x to the 1 over x is basically 1. This is what we used. Next is example, evaluate limit x tends to 0 plus x to the 2 over x. You see that? The base is x. That's okay. But the x is in the numerator, in the exponent too. So in that case, see on this example too, 1 plus x to the 3 over x. So in such cases, what we do is we take y equals to, what you do is let y equals to x to the 2 over x, and then we take natural log on both sides, okay? Then natural log of y is equals to natural log of x to the 2 over x. So this can be written as 2 over x goes to the front of the natural log, and then that x stays like that. So basically you can write 2 natural log of x over x. You see that? So now let's take the limit. Then limit x tends to 0 plus natural log of y is equals to limit x tends to 0 plus 2 natural log of x over x. So if you plug in the limit here, what form do you get? Let's simplify this, okay? You can write limit x tends to 0 plus, right? You can write 2 over x times natural log of x, because it is not the 0 over 0 form. That's why I just separate that. If you do that, what do you get? Limit x tends to 0 plus 2 over x is infinity, positive infinity, times when x tends to 0, then natural log of x will be negative infinity. Basically, you got negative infinity there. The limit is negative infinity. So you cannot use the L'Hopital's rule here. You cannot use L'Hopital's rule here. Okay, because it is not in the form of 0 over 0 or infinity over infinity or anything. You see that from here to, if you plug in here, so what do you get? So basically you get 0 to the infinity. So 0 to the infinity is not indeterminate form. So it is not indeterminate form. Okay, no, not indeterminate form. If it was infinity to the 0, that would be indeterminate form, but this is not. So you can guess from here too, but if there is x in the exponent and then there is just one term and then x to the x something over x or just x in the exponent, we usually take y, we write y equals to that and then take natural log on both sides. Okay, that's the idea. Okay, so let's do that. So what we got is we got limit x tends to 0 plus natural log of y is equals to negative infinity. So how do I get rid of natural log of y? Therefore y is basically e to the negative infinity, right? Because this natural log of y can be written as log of y with base e equals to negative infinity. That's what it means, right? So if you want to get rid of the log, then what you write is y equals to the base to the other side, right? So that's what you write. So you get limit y tends to 0 plus, sorry, x tends to 0 plus y. What is y? Y is x to the 2 over x, right? Is basically e to the negative infinity. So what is the value of e to the negative infinity? It is 0, right? Because it is basically 1 over e to the infinity, right? So if you divide, e to the infinity is very big number. 1 over a very big number is almost 0. So the answer to this question is basically, so limit x tends to 0 plus x to the 2 over x is basically 0. Okay, so let us look at this example. Find limit x tends to 0 plus 1 plus x to the 3 over x. You can see, you can guess your answer, like plug in 0. So you will get 1 plus 0 to the 3 over 0. It is basically 1 to the infinity. It is indeterminate form. This is indeterminate form. So we try to get that, we try to use the L'Hopital's rule. But before we do that, you need to think that as y equals, let y equals, because that is x in the exponent. Okay, let's do that. Let y equals to 1 plus x to the 3 over x. Now take the natural log. If you take the natural log, you will get natural log of y equals to natural log of 1 plus x to the 3 over x. Okay, for the natural log, that thing goes to the front. So I write natural log of y equals to 3 over x times 1 plus x. Natural log equals to 3 natural log of 1 plus x over x. You can do that way. Now take the limit. Limit x tends to 0 plus natural log of y equals to limit x tends to 0 plus 3 natural log of 1 plus x over x. If you plug in the limit, what do you get? You will get 3 times natural log of 1 plus 0 is natural log of 1 is 0 times 3 is 0. So you will look like 0 over 0. That's what you get if you plug in the limit there. Okay. So now you can use the L'Hopital's rule. L'Hopital's rule. So this is equals to limit x tends to 0 plus. You can think this as like a natural log of u, right? You can think this as like a natural log of u. So what is the derivative of natural log of u? So let me write down 3 here. Times natural log of u is 1 over u times the u prime over the derivative of x. So the derivative of the top and the derivative of the bottom separately. So L'Hopital's rule says that you can find the derivative of the top separately. Derivative of the bottom is 1 there. Okay. So let me plug in the value. 3 times natural log of limit x tends to 0 plus 1 over 1 plus x times, what is the u prime? This is basically u prime. Okay guys, so this is basically u and then prime. Okay, so the derivative of that is u, 1 over u is 1 over 1 plus x. The derivative of 1 plus x is just 1 divided by 1, right? So now plug in the limit. 1 over 1 plus 0 is just 1. So basically 3. That is the derivative of the limit of natural log of y. But what is y though? You need to get rid of natural log. So let me write down that thing. So limit x tends to 0 plus natural log of y is equals to 3. But what is natural log of y means? That means log of y with base e equals to 3. But how do we get rid of log there? E to the 3, right? So limit, so you can write limit x tends to 0, y is equals to e to the third, that is e cubed. That is the final answer. What is y? Y is that value, right? Therefore its limit of y is e to the third. That is the final answer.